Boom! Yes, folks, Hume here again. How are you going? So we're going to start in this video a series where we're going to discuss the multiplication and the division of fractions. All right? That is one of the core fundamental skills in algebra at any level. So it is important to know what to do when you multiply into fractions and when you divide into fractions. Once you could do that, you could extend the argument now. You could extend the technique to maybe 3 and 4 fractions, but you have to master 2 first. So let me start. We know that all fractions are composed of a numerator and a denominator. So let us say, for example, we have fraction 1, numerator over denominator, and we have fraction 2, numerator 2 over denominator 2. Right? So if we multiply in those two generic fractions, what do we do? Anytime you multiply in two fractions, the basic fundamental thing that you want to do is multiply horizontally. What do I mean by that? All I mean is that you multiply the two numerators by each other and you multiply the two denominators by each other. So that when you multiply n1 over d1 by n2 over d2, what you're supposed to get would be n1 by n2 over d1 by d2. It's looking complicated, right? It's looking strange. It's looking hard. Watch how easy it is. If I say, and I'm going to use the example that I have here, let me say we have 2/3 multiplied by 5 over 7, right? Fraction, n1 over d1, n2 over d2, right? This will give you what as the answer. 2 by 5 is 10, 3 by 7 is 21. That is it. That is it. That is all that you have to do when you multiply into fractions. That is the foundation. But of course, we know, usually in maths, even when the foundation is straightforward, as you start to put the thing together, it gets a little more complicated. So for example, if we have, let me chuck him in the corner here. If we have 2 over 3 multiplied by 6 over 7, we could do one of two things. We could do as we did and multiply the two numerators. We can multiply the two numerators and get 2 by 6 is 12, 7 by 3 is 21. We get 12 over 21. In which case, now, the whole question of expressing the fraction in its lowest possible terms enters the picture. Which then goes back to another series of videos that I did on factors and primes and all of that. So in other words, if you could identify common factors in the numerator and the denominator, then you have the basis for doing what we refer to as reducing the fraction. You reduce the fraction to its lowest, what's the term by? To its lowest terms. You reduce it to a fraction in its lowest terms. So in other words, 12 over 21 is 12 over 21. But that is not the simplest value of 12 over 21 because 3 is a factor of 12. 3 is also a factor of 21. So if you divide the numerator and the denominator by 3, what you will actually get would be what? This will be equal to 4 over 7. Right? Yeah. So you could take the 3 as a common factor here, or you could take the 3 as a common factor here. Because 3 is a factor of 3, obviously, and 3 is a factor of 6. So let me see. Let me steal some space on this side here. So if you have 2 over 3 by 6 over 7, we write it over here now. Right? Aye. This is what you have to go through when you have more than one marker in your hand. Eh? Sometimes one drop. So if you have 2 over 3 multiplied by 6 over 7, and you look and you see 3 is a factor here and 3 is a factor here, well, look at that. 3 and 3, 1. 3 and 6, 2. 2 by 2 is 4. 1 by 7 is 7. So the same 4 over 7 that you get here, when I identify 3 as a common factor in this state, versus multiplying out here and then identifying 3 as a common factor here, you get the same 4 over 7. So there will be times when you have the ability to divide the numerator and the denominator, which means, well, you divide the numerator and the denominator by the same factor as you did here, or you could identify the factor in this written form here and get the same answer. Right? Let me do our next one just to illustrate. So suppose you have, let me rub it off here again. Suppose you have, right? So I'm just illustrating the ones where you're cancelling now. Suppose you have 7 over 3, yeah? Suppose you have 7 over 3 multiplied by 5 over 7. Right, so watch. Yeah, you'll see the 7 on top here and the 7 below. So you know immediately that the 7 is a factor common to both. 7 into 7, 1. 7 into 7, 1. That is equal to 5 by 1 is 5. 3 by 1 is 3. So in other words, after you divide by 3, you still have to come now and do the same thing that we just did here, which is to multiply the numerators and multiply the denominators. So what it basically means is that you could either do the division first and then multiply afterwards, as we did here, or as we're going to do now, you have the option, of multiplying first, as in 7 by 5 is 35, 3 by 7 is 21. You multiply first, numerator by numerator, denominator by denominator, following which you then divide, because you recognize that 7 is a factor of 35 and 7 is a factor of 21. So in other words, 7 is a common factor in the numerator and the denominator. 7 into 35 is 5. 7 into 21 is 3. 5 over 3. 5 over 3. So the essential thing, the core, let me call it the common core, that all multiplication of fractions, the common core of all multiplication of fractions is this here in black. You multiply the numerators by each other and then multiply the denominators by each other. That is what it is. You might have the situations where you have the ability to divide, having identified a common factor in your numerators and your denominators. So you identify the common factors here, so you cancel, or you cancel and then you multiply, and or, as in this case, you multiply first and then you identify the common factors. Boom. Same answer. And that's it. So that's the first video in the series where we get to some other stuff now. Stay tuned.